Welcome back to Homework Help with Miss Gore. Today we're going to be talking about our Unit 9, Day 6, our quadratic word problems. So my sheet looks a little bit different than yours. I just added a little space to mine. So what I'm going to do for you today is I'm going to help set up a few of these problems, and you're going to have to come to class with these finished. All right, so the first one says the square of a number added to 3 times the number is 28. Find the number. So we're going to start by making a let statement. So we are going to let x equal some number. So now I'm going to read through this again. The square of a number, so a number squared, added to 3 times the number is 28. Now it's up to you on how you want to solve this. Is it factorable? Do you have to use quadratic formula? Can you complete the square? So find a method that works best for you. Number 2, it says the product of 2 consecutive odd integers is 143. Find the integers. So first, let's start with defining our variables. So let's let x equal our first integer. So we'll know at the very end that our answer has to be a positive or negative whole number. Now, if I want them to be odd, if I want the next odd number, I need to add 2 to my number to now get my second integer. So the question here says the product of the 2. So I'm going to multiply x times x plus 2, and I know that this is equal to 143. Now I need you then to distribute, and you're going to end up with a quadratic. So again, you're going to decide, is this factorable? Do I need quadratic formula? Is there another way that I could solve this problem? Okay. Let's talk about number 3. Number 3 says the length of a rectangular garden is 4 meters more than the width. So I'm going to draw myself a rectangular garden where my length is 4 meters more than the width. So I'm going to use my width as W, and 4 meters more than that, I'm going to say that that's W plus 4. It says that the area is 60 square meters. So I'm going to use my formula, area equals length times width, or base times height if you're familiar with that. So I'm going to be multiplying W times W plus 4, and oh wait, I know what the actual area is. I know that my area is 60. So again, I'm going to distribute, I'm going to isolate that W, and then I'm going to have a quadratic equation. So I need to decide, is this factorable? Do I need to use the quadratic formula? So on and so forth. Okay. Let's take a look at number 4. The altitude or the height of a parallelogram measured 11 centimeters less than the base. So let's draw ourselves a parallelogram. Now when I'm finding the height of my parallelogram, I drop a perpendicular line, and it says that the height is 11 centimeters less than the base. So it means I'm going to call my base x, and if I want to say 11 less than that, I'm going to say x minus 11. Now it says that the area is 80 centimeters squared, and again, I'm going to use the same formula I used before. Area equals base times height, same as length times width. So I know that my area is 80, and I know that my base is x, my height is x minus 11. Again, look at this. I'm working out to be a quadratic. Okay, so again, same advice. Is it factorable? Do you need quadratic formula? Is there some method that you like to solve this rather than others? All right, question 5. The ratio of the measures of the length and width of a rectangle is 5 to 7. So I'm going to draw myself a rectangle. And remember, algebraically, if I have sides in a ratio, I'm going to call them 5x and 7x. It says the area is 1,715 feet squared. So I'm going to take my 5x, multiply by my 7x, and I know that that equals 1,715 feet squared. Multiply these together, and again, this is going to work out to be a quadratic. So figure out how you're going to solve the problem. All right, now I'm going to skip a couple, okay, that are very similar to the others, and let's talk about number 9. Okay, so number 9 says the altitude of a triangle measures 5 centimeters less than its base. So I'm going to draw myself a triangle. I'm going to include my altitude. And again, my altitude is perpendicular to my base. And it says that the altitude is 5 centimeters less than the base. So this is x and x minus 5. It says the area is 42 centimeters squared. So my formula for area of a triangle, area equals 1/2 base times height. I know my area is 42. 1/2, my base we said was x, and my height, x minus 5. So one thing I could do first to get this started is, if I want to get rid of this fraction here, I could just multiply both sides by 2. So I now have 84 equals x times x minus 5. So we'll distribute, and again, solve the quadratic in any possible way. Okay, let's skip now to number 10. No, I'm sorry, let's do number 12. Number 12 says that the perimeter of a rectangle is 54 centimeters and it gives me the area. Unfortunately, I don't know anything about the relationship between the length and the width. So what I might need to do is call one of them x and the other one I might need to give a new variable. So I know that the perimeter is 54. So I know that if I take 2 x's and 2 y's, that together that has to be 54 centimeters. Now, that's my perimeter. Now, my area would tell me that x times y equals 140. I now need to take these two equations together and somehow solve it in order to isolate my x and my y values. So one possibility that we have is that we could solve one of these for a variable and plug it in for the other one. Now, it's really not going to matter which way we do it here. So why don't we just solve for x? Okay, so let's subtract our 2y over here. So I have 2x equals 54 minus 2y. Divide this by 2. X now equals 54 divided by 2 is going to give me 27 minus y. I can now take my 27 minus y and I can plug it in right here. I now have a 27 minus y times a y equals 140. Distribute, distribute. I have a quadratic. So get that equal to 0. If it's factorable, factor it. If not, use the quadratic formula. And I will see you in class very soon. Have a great day.